So here's a quick little video showing some updates on the FM radar stuff that I've been working on. This is the basic FM continuous wave radar hardware that I've shown previously in my last video. Just to give you a bit of a recap, here's the VCO. This wire brings in the modulation waveform that drives the varactor. Here's an MMIC gain block that amplifies the VCO output. There's a little attenuator there as well to set the amplifier drive level so we're not saturating it. This is a Wilkinson divider that splits the RF coming out of that amp in half, and half of that RF gets transmitted out the transmit antenna here, and half of that RF goes into another gain block here, and the output there is basically the local oscillator, and that goes over here to this other section. This is the receiver antenna, this is the low noise amplifier, this is the mixer, and the local oscillator comes into the mixer here, and the IF output goes over here to this board where the filtering and amplification of the IF occurs. Here I'm just using a little Mini Circuits MCA60 mixer just temporarily. I want to try and move over to entirely using Hittite components because they're a bit easier to get from distributors like DigiKey, easier to get small volumes anywhere in the world, but I'm just working with sort of Lego Meccano sort of architecture just for prototyping and experimental purposes. This is really not what the finished product will look like. It's really just a developmental experiment in progress. Just to give you a sort of visual or artistic impression of what I think the finished board might look like, it might look something a bit like this. This is an early board that I've been experimenting with. I'm not using this board at the moment, but it probably gives you a bit of a visual artistic impression of what the finished product will look like on a custom single PCB. I'm not going to spin another custom PCB until I'm satisfied that the RF chain is working properly. So just imagine that we have two antennas here and here, the receive antenna, the transmit antenna. If you've never seen hardline conformable semi-rigid coax before, that's sort of what it looks like, that solid metal covered coax. So just imagine that we've got a single board here connected to the antennas, and that does our RF chain, our IF amplification, our filtering, our baseband frequency analysis, and gives us a product out which gives us altitude or velocity information out into the flight computer. This is a prototype of the IF amplifier filter board that I've been playing with. This is a different circuit to the one that's over there on the breadboard. I'm just playing with a few different circuits in the amplifier filter chain for the IF. But probably the finished product will be a board about that size, using all surface mount components on a bespoke board, and that'll have two connections for the antennas, as well as some power and data connections out to the flight computer in your UAV or aircraft or whatever. Here are some other little odds and ends, modular components that I've been playing with just for experimental purposes, although they won't be used in the finished product. This is a little Wilkinson divider. If you've never seen a Wilkinson divider before, it's one of those magic little microwave components that just uses a squiggle on a PCB basically that has the right geometry, and that gives you a functional device. You often see this sort of distributed technology in microwave systems for filters, bias tees, things like that. That's distributed microstrip technology, which is a little bit of black magic if you've never seen it before. That's really one of the things that I wanted to do with this project, is to demystify a bit of RF engineering, to make it a little bit more accessible and just sort of show people this sort of technology. They may not have seen a lot of RF stuff before, and you know, maybe radar is a little bit of a niche thing. You may not use radar every day, but you certainly use microwave RF every day, whether it's Wi-Fi or Bluetooth or whatever. So everyone is using RF everywhere all the time, but it's a bit of a black box thing. So maybe we can try and make it a bit of accessible and show people that it's not black magic. It's actually just engineering, just like any other. These are some of my other little experimental blocks. That's a Hittite HMC219 mixer, double balance mixer. That one's a level 11 mixer, so unlike the Mini Circuits one, it needs its local oscillator to be a bit of high level. That's a Hittite 717 low noise amplifier. That's the same as the LNA that's over there on plugged into the antenna. So this is a HMC 476 gain block, just like the other ones that I've been using. So this is the circuit as it stands at the moment. I can just turn that on, and what we will see there is the VCO modulation waveform that goes from about 2 volts up to about 9 volts. So that's modulating the varactor in the VCO, which sweeps our frequency up and down in a sawtooth way. That channel 2 there, channel 1 that you can see there on the oscilloscope, is actually the amplified IF output. That's not behaving itself at the moment, unfortunately, so I can't show you the entire working radar system actually responding to reflection off an object. I'm still having a little bit of trouble with one of the RF amplifiers, unfortunately, and when you've got it's a bit tricky to debug this sort of system when you don't have a 6 GHz spectrum analyzer, an RF power meter, and that sort of RF instrumentation. So you just sort of have to cross your fingers that you're pumping RF out, you're getting RF back into both sides of the mixer, and you're getting a baseband product out of the mixer that you can work with, and it either all works or it doesn't. And if it doesn't all work, it's really hard to kind of chase the RF through the system to figure out where you're losing the RF. So I still have a little bit of work to do, not completely out of the woods yet. It's still a work in progress, although I have made some good progress in some areas. I've kind of gone for a bit of a retrograde approach here. I started off with a bespoke PCB, and I've sort of gone back to a Lego approach on the breadboard, just so that I can experiment with the circuit a bit, get it to work in a way that I'm happy with, and then go back to a bespoke PCB for the final finished product. That's the sort of aim that I'm hoping to eventually get to. But once I have a circuit that I know works, it's easy to spin a bespoke PCB up. I never did any formal RF design or microwave design at school. It's one of those subjects that I wish I did at uni but never did. So I'm just sort of self-taught microwave electronics. I just thought that was something a bit challenging to teach myself, but not because it's easy, but because it's hard. And I wanted to demystify it and make it a little bit more accessible, not just for everybody else out there that's watching, but also for myself as well. So it's a bit of a stretch. It is a bit of a niche. It's a hard niche of engineering, and I just wanted to push the boundaries of what's accessible, not just for everybody else, but for me as well, and to give myself a bit of a challenge and expand my own knowledge a bit. It's coming along, but there's still a little bit of work to do. If you have any further questions or comments, or you want more details about the schematic or anything, please post a comment on Hackaday or on YouTube or whatever, and thanks a lot for watching.